Can everyone hear me? Yeah, I guess it's yes. Let's get started. And I wanted to just give a quick little video on some of the great advances of computer technology and how it can help our society. Hopefully the video quality is not too grainy.
We have in our possession a chip that could revolutionize medicine as we know it. By performing 100 billion operations a second, this chip could help us heal across continents. We could touch more lives, help people live longer than ever, and give us all more time to cherish the journey's truest rewards. But then we thought, hey, let's use it for games.
FX PC accelerators. So powerful, it's kind of ridiculous. That game's a little violent for my taste.
Sorry, that's just an old commercial that kind of embodies my interest in games. Like, you can do a lot of great, helpful stuff, but it's all about having fun. So, welcome to Developing Games, my talk. I'll give you a quick take on my life as a computer technologist. I fell in love with video games at the age of 5. That's when I first became really interested into it. You know, friends that had Ataris and thought it was the coolest thing in the world. And I begged and begged and begged my parents to allow me to get a Nintendo for Christmas. And of course, they said no, it would ruin my brain. I'd never study. I'd never go to school. I'd never make anything of my life. And I cried and I threw temper tantrums, and they just wouldn't budge that one. But luckily for me, my father actually worked with computers at the time, and he brought home one of his computers from work, and he told me that there's this one directory in the computer that has games in it. If you learn how to use the computer, then, you get to play games. Of course, I was excited. So from there, I went on to get 2 degrees in computer science. I learned to start programming at the age of 15. You mentioned already, I've had a chance to work at Microsoft working on games. I worked on this one shown here. This is Project Gotham Racing 3. I worked on Project Gotham Racing 4 and Forza. Some time with MySpace working on some of their web components, and I feel comfortable saying that I pretty much made my career of making entertaining experiences with computer technologies. It's what I've loved since a little kid and what I've been very fortunate to make a career of. So at this point, I actually wanted to say that due to the time constraint, I'm going to focus mainly on games. They're a little bit more visual, and I've had a little bit more time, I guess, doing that. So most of the stuff that I'm going to talk about is applicable to both games, web development, or just about anything with computers. So if I miss something that you're interested in, feel free to ask me questions about it. I look forward to answering those. So into the world of game development. Very simple example here, Tetris, one of the classics, one of my favorite. And I wanted to use this as I go along to sort of talk about the different layers of the development process and people that are involved with it. So let's first start by looking at the team. These are the core positions that people play in it. We'll start with the producer. This is the person who, he's kind of, I guess, like the glue of the team. He's responsible for running the schedule, making sure everything gets done. A traditional AAA title, like the stuff you'll see that comes out at Christmas, a Halo, Gears of War, those type of games can consistently take 2 years, 3 years, or more. So you need someone who just makes sure that all the components are coming in on time and they actually work and are as expected. Then there's the game designer. The game designer is sort of the creative vision of the game. He's the guy that's going to say, like for the game Tetris, I want to drop 4 blocks at a time, and when you complete a full row, let's clear it. Then there are the artists. They're the persons that are responsible for the look and the feel of the game. In this example, of course, they're going to color the blocks, have a cool sound effect when you clear the lines, et cetera, et cetera. Then there's the developer. The difference between, say, a video game and like a cartoon, both of them have flickering images that you see, but a cartoon is just scripted. It's always the same sequence over and over again. But with the game, it's interactive. It's based on what input you put into it, what your friends are doing, what's coming in over the network. The developer is responsible for taking those artists' images and sounds and making it into an interactive world. And then there's the testers. These guys are probably the person most likely to tell someone what they do for a living and have the person answer back, oh, so you just like sit around and play video games all day, which is definitely not the case. There's definitely a lot of manual testing where they play the game, but they play it in various states of the game when it's not working, and a lot of them actually are developers that work on creating systems to automate different mechanics of the game so they can cover like the full range of features that are going to be in the final game. So if you noticed, the biggest title on that, of course, was developer. That's what I do. I write code. I'm a software developer. My training is in computer science, and that's the tool set that we use to build the code to create the virtual worlds that make games as exciting as they are. So why is that cool? Why do I think that that is like the ultimate place to be in the world of game development? So I use this example here. It's a bit of a stretch, but work with me, and I think you'll hopefully find it as cool as I do. When I was getting my master's degree, one of the schools that I visited was UNC and University of North Carolina. And they had this room where you walk in and there's just like this wooden board all the way around. You can kind of see it here. And in the middle there's carpet. And the carpet is maybe about 5 inches or so lower than the wooden board. And you'll notice that the person that's in the room has this virtual headset on. And what the person is seeing, hopefully that makes sense, is this. There's a wooden frame around the top of it, and then there's a room that's about 10 feet down. So you put the headset on, and you're walking around, you feel the wooden plank, and you look down, and you see there's a room 10 feet down. And you put your foot over the wooden plank, and you got this moment of fear before your foot hits the carpet where you realize that you think that you're in this virtual world, but you're not. The point of this example that I'm bringing up is quite simply that all engineers create stuff. That's, we take math, we take science, and we get to build stuff. But the great thing about computer science is we also get to create our own worlds, and then we create the objects in them. So, the last presentation was about, creating tall buildings, and he has to worry about the wind factors. Well, I can just take the wind out of my world, and it's a lot easier. I get that type of flexibility, and to me, that's what's really exciting about it. We're limited by our creativity, not by, just the limits of science. We understand it, we work with it, we model it, but we get to play with that too. So how do we do it? We write code. So I'm not too familiar with everyone in this audience. Like, I understand you guys are in middle school and high school. Is that correct, mostly? Yeah. Awesome. Have people started coding yet? Do people know what code is? A couple. Okay, see a couple hands. All right, cool. What languages are you using? Nice, very nice. I saw another hand over here. What language do you code in? All right, well, anyway, let me jump back a step. When I talk about coding, I'm talking about, we use different programming languages such as Java, as you mentioned, C, C++, C#, etc. And what we do with these is we write a series of instructions that get translated into operations that a computer will run. So the most common tools that we use within these languages are the concepts of functions, which are basically a small group of instructions that we can group together and use at any given time. Within those, we'll use loops, which is basically the idea that if we have a set of logic that we want to run over and over again, instead of just writing it over and over again, the same set of steps, we'll tell the code, do this 100 times, and then when we're done, we're happy. Then we have variables. This is where we store the data that we're keeping from, the different instructions that we're using. And then we have conditional statements. So as we're walking through the code, we can decide at this given time, if something is true, then we'll do something. If not, we'll do something else. Hopefully, did that make sense? Yeah. Sweet. All right. Back in the world of Tetris. I mentioned before that we use like loops to do repetitive code. So the goal of this little block of code is to figure out if there are any full lines here and get rid of them. The classic problem of Tetris. When you fill a line, clear it, get more points, keep playing. So we have a variable y that's an integer, which is basically just a simple number. And we're going to count from when it's 0 to the height and the number of rows, y plus plus. So plus plus means when you're done with that instruction, just go up to the next line. The first thing we ask with the conditional statement is the line that we're on full. So if we looked at this one when this piece drops, no. And that's what this function is going to do, is evaluate each line.